Welcome back to the Joy of Code, episode 5. I'm Michael Kölling, and we are going to continue straight off from where we left off in the last episode with a turtle scenario. And over the next few sessions, we will turn this into a little computer game. So we want to create a bit more sophisticated movement first. Let's get started straight away. Here we have the same scenario that we had in the last episode, the trick the turtle scenario, in exactly the state where we left off last time. So I have my turtle here that I can create an object of, and when I run this, my turtle runs in a circle. So what we want to do now is we want to make the turtle actually react to its environment. Specifically, we want to make it react to the edge of the screen. Before we had it running in straight lines, I'm taking the turn out here to make it run straight again. Before, so that we had before, when it runs, when it hits the edge of the screen, it just stops there. It's actually trying to go further, but it can't go out of the world, so it gets stuck here. So what I want to do now is I want my turtle to go forward in a straight line, but when it hits the edge of the world, I want it to turn around and come back. Let's see how we do that. There is a method in the animal class that can help us do that. So if we open up the animal class, we can actually, here we see the whole source code of the animal class. We can switch this here to the documentation to just see the documentation of the animal class instead of seeing the whole source code. And then we can see that this class has 3 methods here, and there's one here called @worldEdge. This there's a comment for this method that says this tests if we are close to one of the edges of the world. This sounds exactly like what we need to do our turning at the edge of the world. We should also be able to call this method directly here. If I right click on my turtle, that came from the animal class, so I look at the inherited methods from the animal class, and there is @worldEdge. @worldEdge here we can see returns a Boolean value. A Boolean value, remember, was an answer that just says true or false. It tells us yes, true, we are at the edge of the world, or it says false, no, we're not at the edge of the world. So let's try that out now. I invoke this method, and it says, in this case, it returned false, so we're not at the edge of the world, which is correct. We can see that we're not at the edge of the world. If I move my turtle over here and put it right at the edge, and then I call @worldEdge again, this time it says true. Now we are at the edge of the world. So I want to write code here that not just says move and turn. I want to say move forward, and if we are at the edge of the world, then turn around. To do this, we will use 2 things. We will use the @worldEdge method that we've just looked at, and we will use a new kind of statement. It's called an if statement that lets us express exactly what I said before. Let's have a quick look at what that looks like. First of all, the @worldEdge method. The specification of the method looked like this. Here is the return type that tells us and returns a Boolean when we call it. There's the name of the method. And then there is an empty pair of brackets. Remember, the third bit between the round parentheses here was the specification of the parameters. So this tells us that this method expects no parameters at all. If a method has no parameters, the parentheses to specify the parameter are still there. There is just nothing in between them. So this tells me I have a method called @worldEdge that expects no parameters and will answer back with a Boolean. So to call this method, I just write the name of the method, and then because it expects no parameters, I give it no parameters. I still have to write the round parentheses when I call this method, so I write @worldEdge with the parameters, but nothing in between, because this method does not expect any parameters. When I call this method, this will answer back with either true or false to me. Okay, that's the first thing to keep in mind. The second thing to look at is an if statement. An if statement in Java looks like this. There is the word if, and then in round parentheses a condition, and then between curly brackets one or more statements. And we read it like this. When this if statement executes, it will say that if this condition is true, then we will execute these statements. If that condition is not true, we just don't do anything. So these statements are run only when that condition is true. So this condition has to be something that is either true or false. Now we have just seen that our @WorldEdge method gives us true or false. So in place of the condition here, we can just use that method. And then we say if @WorldEdge, and here instead of in place of the statement, we will use turn. So essentially we're saying if we are at the edge of the world, then turn. Let's try that out. So here we move in any case, and then we say if, one round parentheses is enough, if @WorldEdge, that gives me my condition, and then here I write a pair of curly brackets. A pair of curly brackets in Java is also called a block. A block groups one or more statements, so that can group multiple statements and say these all belong to that if statement. So I say if @WorldEdge, then I want to turn some angle, let's say 13 degrees. I don't really care so much. You also see that in Greenfoot actually you get a sort of colored background in the editor. So here this grayish color shows you that this is the if statement. That yellowish color shows you this is your method, your act method, and the green around it shows you that this is your whole class, the class turtle. Let's try that out, see what this does. I have compiled, I place a turtle into my world, and it goes, and there it turns around. I can place another turtle. Let's place a few more turtles into the world. And they are all going around my world. And as soon as they hit any of the edges, they turn. Now, one quick remark here about the angle. I've just chosen some somewhat random number, and you may wonder why this is turning. A lot of people, when they try this first, think of it as, well, I'm running here across the edge, I want to turn around, so if I want to turn around the whole way, that would be 180 degrees. We can turn 180. Let's see what that does. So a lot of people try this at first, and that's not wrong, but it looks slightly different. Let's have a quick look at that. So here it goes to the edge of the world and then sort of bounces back. What's actually doing here, if we look at that slowly, so if we get close to the edge here, and then I click, instead of clicking run, I'm clicking act, so that we can see this running step by step. Every time I act, now it's going forward, and there it just turned around. And in a single step, it turns around completely from facing to the left to facing to the right in a single step. So the result is that we get a very sudden turn. There's this sort of very abrupt effect of this bouncing to the other side. Now, if I choose a smaller angle here, some random smallish number of degrees, so here I've just said 7 degrees, and I place the turtle in. Now look closely at what it looks like when the turtle turns at the edge of the world. Now this looks much nicer. See, the turtle turns much more slowly. But if I turn only 7 degrees, how then does it work that I'm actually getting the whole way around? Well, the answer is quite simple. Once I get close to the edge of the world, I'm getting here, then I am at the edge of the world, then the turtle will turn, but it turns only 7 degrees, so it turns only a little bit. It does not turn all the way around, it just turns a little bit, and in the next step it is still close to the edge of the world and it turns a bit more. In the next step it turns, it's still at the edge and turns another 7 degrees, and then it's still at the edge and turns another 7 degrees, and finally, eventually, it will come round and face away from the edge again and then move away. And what happens then, we can see now, is it's turning in multiple steps. And this turning in multiple steps gives a much more smooth looking, much nicer looking animation. That is one of the secrets of animation. Well, not really secret. It's one of the very well known things about animation is if you move in smaller steps, the animation looks nicer. So to move slowly around and get a nicer looking animation, just move a little bit at a time, and just then you will just move multiple times and eventually come around as well. Okay, that was the first look at an if statement. We will see that if statements are very handy, they're very powerful, we will use them a lot. Typically we don't want the same thing to happen all the time when we program. We want some things to happen only in certain conditions. In this case, when we're at the edge of the world, is saying we move in any case, and if we are at the edge of the world, then we also turn. Make sure you understand this. We will practice a lot more with if statements a bit later on.